request of all to maintain the decorum for the event. So thanks a lot again for joining today, and I will start with a very brief introduction about the session itself today. So let me just get going with the presentation. So I welcome you all to this joint presentation organized by IIT Mumbai Local Network and the ICE Mumbai. The topic that we are going to hear about today is Hyperloop, a modern transportation system. I think a lot of us have heard about what Hyperloop is. It will be interesting to hear from Dr. Sabih Khisaf about the subject itself, who works for Hyperloop Technologies, and we'll know more about that in details. Talking about, I would like to give a brief introduction about IC. The IC is the Institution of Civil Engineers of the UK, with more than 95,000 members globally across 162 countries. We are a professional institution, a not-for-profit organization, essentially built for the benefit of members, for the benefit of civil engineers and fraternity at large. Benefits of becoming a member, as you see, typically events of this kind are organized by ICE, and we constantly are working very closely with our members to offer these benefits to the members and to the fraternity at large by offering networking events like these, conferences, and of course site visits are not happening these days because of the lockdown, but we hope once the economy opens out, we should be able to do some very interesting site visits going forward. We also support our members for the continual development, and we aim to achieve this through various mentoring schemes, qualifications, and learning hub. All these tools are available online, and you can feel free to approach me in case you need any support to access these. So the industry connect is also quite significant. Magazines like New Civil Engineer are extremely popular. They have really the latest update on what's going on within the civil engineering world across the globe. Memberships are of different categories, starting from the very basic graduate membership to a full member and a fellow member, which is the highest grade of membership. And there are also technician members and associate members available. Technician members primarily for engineering technicians, and associate for those who are not civil engineers but are interested in civil engineering or in some way or the other connected to the civil engineering world and would like to seek more understanding of what's happening within the world itself. Right. So I hope you are all able to see my screen. Right. So how do we perform these outreach programs? And this is essentially done by events like what we are attending today. This is the 27th edition of Genesis. Genesis was launched way back in 2016, and we have been consistently working at trying to bring very high quality tech talks for the benefit of civil engineers and the fraternity at large. So if you have any suggestions to make in terms of the topics that we can host, we can talk about, feel free to connect with me, and I will be more than happy to help subsequently. In addition to various tech talks, we also organize site visits. We have done some very interesting site visits. For example, we visited the TBM construction site in Mumbai. We also visited the Sardar Vallabhbhai Patel statue, which is the tallest in the world right now, and it was an interesting site visit for a lot of our professionals. So that's me. That's your ICE contact in Mumbai region. Those are my coordinates. I am also one of the 3 approved mentors. So if there are any professionals who are civil engineers and would and aspire to become chartered, feel free to approach me. and I'll be able to provide help to the extent possible. Uh, so those are the additional handles available across various media channels of IC. Talking about the speaker today, Sabih Khisaf, he is the head of engineering in the MENA region for Hyperloop Technologies. With more than 35 years experience in the transportation sector, has worked across multiple different geographies, has got a significant experience in the transportation sector, and just recently he has been appointed to the trustee board of the IC. I really feel proud to have been friends with him. I worked with him very closely as one of the professional reviewers, and it's been very enlightening to have him today. So, Sabi, from this point over to you. Thank you very much. So, Sabi, would you like to take over? I think you're muted right now.
Thank you very much, Rajesh. Sorry, blame it on IT. I'm not very expert on all these technologies, but I try to do my best. Thanks for the introduction. And yes, it's an honor to be friend with you. And thanks for helping on the reviews. And I hope to see you soon when all this behind us. And thanks, IC Mumbai. It's a pleasure. And thank you very much for everyone who's listening. It's an honor to speak to you. As Rajesh said, just briefly about myself, I work for the Hyperloop Transportation Technology as head of engineering, and I'm also involved with the ICE in UAE. I'm the chairman of the local committee. For tonight, I will try to, let's see, can you see my screen, Rajesh?
Not yet, Sabi.
Okay, let me see if I can sort this. Okay. Where is the share screen? Sorry, just, okay. Yeah, can you see it now?
Yeah, it's just come up.
Okay, good. Let me put in transfer. Yes, thank you very much, everyone, for this evening. I will be talking just at the beginning briefly about transportation of today and where we started with the current mode of transport and how it's all started. And also I will talk in much more details about Hyperloop as a technology and the advantages, disadvantages, and the main component, and also the current and future trends of the technology. If we start on transportation, it depends who you speak to. If it's, your daily commute is different from someone try to sell you a car. If you talk to a car dealer, this is the picture. Empty road, good company, and very easy and nice. Beautiful. But this is the reality? When we go to the office, this is what we see. This is the reality of today's transport system. These are the roads, and this could be anywhere around the globe. It's not limited to a city, it's not limited to a country or a continent. Wherever we go, we see the same thing every day, in the morning and the evening. The roads are overcrowded, overloaded, and the journey is overwhelmed. We know when we wake up in the morning, we dread to the time of traveling to the office. And we had to do the same thing when we're coming back from the office. Basically, the stress from the journey is more than the stress from the office and the work we do daily. And the traffic jams everywhere, as I said, and this is the mother of all traffic jams. We all know that basically in China, they have the Chinese New Year, and basically the country is almost shut down for 2 weeks. And this has happened in 2010. Took 11 days to clear, miles and miles of traffic jam, and tens of thousands of vehicles. And this could be anywhere. And these traffic jams have the effect not on us as stress and using our daily commute, but also on pollution. If you look at this picture, this is Beijing in a good day. But that doesn't mean only in Beijing. This could be Mumbai, it could be in Riyadh, you could be in London, you could be anywhere. And this is Beijing in a bad day. Basically, the pollution has big effect on us, on health, and on life expectancy. The graph you see, the numbers you see, this is the number of months lost life expectancy depend on which part of the world you live in. And imagine losing 50 months of your life, but because you live in certain part of the world. It's not sustainable. It can't be continue like that. Also, if you survive the pollution, there is a chance of you dying in a road accident. And again, the figure you see on the screen, this is the percentage of chance of you dying in a road accident around the globe. And these are statistics from the United Nations. The picture of transport on the road, we see it on the rail is not a big difference. And the picture you see is London Underground. I used to work for London Underground until 2007 when I came to work in UAE. And basically, I was facing this journey every day twice. In the morning, coming to the office, and the evening going back home. And it's not just in London. This is Beijing in the rush hour. And not just Beijing, everywhere around the globe, the same picture. London Underground. And trust me, it's not one line of the London Underground, all 10 lines is the same. And this is Sao Paulo. And considering the current situation with all social distancing, try to do this social distancing. It's impossible. You won't make people to do it. And our system is broken. And this is in Japan, most advanced country. This is the way to try to do social distancing here. You will not get anywhere. And it's worse everywhere around the globe. We need to do something to resolve this. It's not sustainable. We talked about road, we talked about rail. Do we think air travel is different? No, it's not. Imagine you're flying somewhere between two cities, between two countries. Imagine until you get to the airport, you have to go through the same hassle either. If you're traveling by car or you're traveling by using public transport, you have the same hassle. When you reach the airport, again, queues until you check in, queues until you do your passport control, and then you have to be 40 minutes before your takeoff, because otherwise you lose the flight. You've done your flight, you reach your destination, the airport, and suddenly you wait to get your luggage. Wait for your luggage, nothing coming. 1 hour, the carousel is closed and no luggage is seen. Your luggage is lost, but they call it unreclaimed. They don't call it lost luggage, they call it unreclaimed. I personally call it stolen from you. You did not reclaim it. You tried to reclaim it, but it didn't arrive. There are good news and bad news. The good news is basically there is a new industry in America where it's called unclaimed package centers. Basically what they do, they do compensate you for your lost luggage. For them, it's easier to compensate than try to find your luggage. And what they do, they sell your luggage in centers. And the good news is you can go to these centers and buy it at 70% of the cost. Again, you can see all the mode of transport currently in place are broken. They need fixing, and we need to do something. And if you think of history of public transport, it started almost 200 years when we started the first steam trains. And then we have the car, we have the airplanes, high-speed trains, and hopefully you have the Concorde, and then hopefully we have the Hyperloop, which is going to fix most of the broken systems. As we said, the current mode of transport is, roads, gridlock, travel, its congestion, and the train systems, current transport system, there is limit on how much and how high speed you can go. As we said, there is a solution, a new mode of transport, a mode of transport that's sustainable, environmentally friendly, and is centric to the user. What is the Hyperloop? I have a small clip which I'm going to run and give you a flavor of what is the Hyperloop. I hope you can hear the, can you hear it?
It's barely audible, Khisaf.
Yeah.
It's barely audible, Sabih.
Okay. How about now? Oh. Sorry, this is the maximum I can do. The Hyperloop, we consider the fourth industrial revolution. The first one we know, it's the invention of the steam power, which started in England, then Detroit with the electrical and mass productions, and then the IT in Silicon Valley. Basically, the Hyperloop is going to be the fourth industrial revolution, and we try to build the first Hyperloop system here in the UAE. The Hyperloop system and the Hyperloop technology is going to change the way we work and the way we live. Basically, it's going to break the continental limit. You can't travel using Hyperloop up to 3,000 kilometers. And in the cities, we know that basically people work in the center of the city, and it's very, very expensive to live in the center of the city, and you have to live outside on the outskirts. But because of the current transport system, the journey is very difficult. With the Hyperloop, you can work in the city and live 50 kilometers from the city, and you'll be able within a minute to travel between your home and your office. It also would have an effect of linking cities, and basically imagine, different cities with high-speed connections. And like if you think of London, London has 5 airports. If you have a Hyperloop connection, you don't need 5 airports. You would have 1 airport, and then you have high-speed Hyperloop system connecting the outskirts of London and surrounding cities. Why Hyperloop? This new technology uses the latest standards in materials, construction, and it's also centric on safety, because a lot of people think the Hyperloop it's unknown and maybe as not safe as other mode of transport. But the reality is it's much safer. It uses the latest technology from sensors, magnets, green technologies, and biometrics. Basically, nowadays, if you go to any airport with the passport controls, the new biometrics technology is becoming standards around the globe. It's like in Singapore, Dubai. You don't need your passport, you don't need your tickets. Based on your biometrics, you can check in, check out, and the same thing is going to be used for the Hyperloop. The system itself, it's enclosed environment. It's inside a protected tube, vacuumed. There is no interference from outside. And we know very well that 70% of road and air accident is caused by either outside intervention or human error. And I have examples, and you know very well when the first high-speed opened recently in India, it stopped its work only 1 day because there was an item on the line and they have to stop the system. The same thing happened in the UK, and please Google it if you don't trust me. The railway station in the southern of England was closed. You know why? Because the station was invaded by cows. With the Hyperloop, it's an enclosed environment. There is no interference from outside. And the biggest problem in the UK for the rail system in the autumn, you have trains delayed. You know why? Leaves on the line. And Google it and you'll see you can't believe train delayed because you have leaves on the line and trains cannot run. With the Hyperloop, this is not the case. The Hyperloop is protected. There is no interface from outside. Again, immune to the weathers, no grade crossings, and we know how many accidents caused by junction between rail and roads. This is not the case. It could be the Hyperloop. It's envisaged to be elevated in its own right of way, no interference with the outside. It also has smart sensors in the capsule, in the tube, and the structure itself. And basically these sensors detect any issues with the system itself and communicate directly to the control center. This way, you can prevent any accidents, and if you need to stop the system can be stopped before the accidents happen. And this gives you the opportunity to have control even on the maintenance. It gives you that if one component it's reaching its limit or it's almost going to break, you can replace it before it's break. The passive magnetic levitation, that give you the opportunity of traveling with no friction, no interface between the track and the wheel. And then it's quiet and clean. Quiet because it's inside a vacuum. There is no rail wheel interaction. And it's because it's a vacuum, there is no noise. And therefore, one of the biggest problem when you're building a high speed around the cities is the noise. And you have to do certain measures to protect the environment surrounding and around the right of way for the high speed. And clean electricity, because if the way the system it's work, it can generate more electricity than its use. And why? If you think of a right of way of almost 12 meters, what you can do, you have a tube and you can put solar panels on top of the tube, and this solar panel will generate electricity for you. The electricity generated is more than the electricity needed for operating the system. And this can be basically the Hyperloop system become an electricity generator than an electricity consumer. And we already start in discussion with different governments, different entities on how we can work on the standards and the connectivity to the local grid. White paper was done in Vancouver in Canada, and the finding is basically based on Canada weather. The system can generate 15% more electricity than its need. Efficient, low cost to all levels. Basically, as I said, as a system, the way the system operate is basically it's because of the components. It's make the system cost effective, because you don't have, if you take a cross section of a high speed train and you take a cross section of a Hyperloop system, the Hyperloop system, you have the supporting structure which is similar to any bridge structure, but the top is a tube. And inside the tube, you don't have signaling system, you don't have track, you don't have ballast, you don't have all the components. You don't have the gantries for electricity, and therefore less components, less cost. Less components, less operational cost. And less components is less maintenance as well. You have less component that could break. This low cost is beneficiary for the users as well, because if you can build a system cheaper and you have a system who can generate electricity, you have more income. You can sell your tickets cheaper than the other systems. Also, it can transport between 28 to 50 passengers per capsule, and the capsule could be at departure time 40 seconds. And the reason for having a close departure time between the capsule is because the capsule and the whole system is completely automated. And that's, as I said earlier, eliminate the human error. And because it's completely automated, and basically the capsule can communicate between themselves, and also they can communicate with the control center. And therefore, there is continuous control. There is no human intervention, it's only human supervision. Also, alternative monetization of the system itself. You can use your journey because you have time, you can use the time reading, writing, watching, and this can be used. Also, sponsorship and people information can be used with their permission to monetize the information. And it's innovative system from construction, from operation, and from the way we generate revenue for the system. And basically we done, I'll touch upon later, we done two big feasibility studies, one in UAE between Abu Dhabi, the capital of UAE, and Al Ain, and the other one in UK, Cleveland, Ohio, and the both feasibility studies, the complete feasibility studies, shows basically the system is efficient and can recoup its cost within 15 to 25 years. We know very well there is no efficient system. All the transport system around the globe is subsidized. The only exception is MTR in Hong Kong. But then the MTR as a system, as business model, is completely different on operation railway. It's more of property development, and basically they generate value for the land, and they link the land, and they selling, and the money they making is more from the property development than from the system itself. But the Hyperloop system could be subsidy free. And these are some figures on the efficiency of the transport system of a Hyperloop compared with the other transport system, and the sustainability of the Hyperloop. As I said earlier, it's used renewable energy, and it can put back in the grid more can it's used, and that's huge in CO2 emission. What is the key components of a Hyperloop system? It's basically the three main components: is the capsule, the structure and supporting structure, and the station. And all the components are designed and optimized to the current and best standards in the world. And we're using the experience and the expertise of all the current industries, from construction, aeronautic, spatial, and so on. And if you talk about the capsule itself is basically can take between 28 and 50 passengers at this stage. This is the first generation of capsule. It's powered by batteries, and the capsule inside has an enhanced experience and centric for the passenger. Basically, as a passenger, you can have an augmented window, which interactive. You can use, if you want to be, you can change, because it's a closed tube and therefore you don't have windows. We have a screen which can be used as a windows, and now this technology start being used by Lufthansa and even Emirates. And basically, it's instead of having a window, you have the screen, and you can change the scenery to whatever you want. And the magnetic levitation, as I said, the magnetic levitation allows you to use magnet to move the capsule instead of the direct current. The tube itself and the support structure is the support structure is for those who have bridge engineers and build bridges. It's basically up to the bearings is the same as any support structure for a bridge. The only difference is what we're going to put on top of the bearings. It's basically, instead of having a bridge deck, it's a tube and a vacuum tube. We only said earlier is basically it's protected from the environment, and the construction of the tube itself. At the stage, we have been using steel as the main construction material, but we also working with different advanced technology companies on concrete, high strength, ultra light concrete, and also composite materials for the tube. And the vacuum is, as we said earlier, is low environment vacuum, and the low environment vacuum allow us to eliminate two main reason for not going fast on a railway system is the friction between wheel and track, and then the air friction. And we know very well that above 650 kilometers an hour, the air become liquid and it's become very, very difficult to penetrate, and therefore there is a limit how fast you can go in open air. And with the low pressure, you eliminate the air friction, and with the magnetic levitation, you eliminate the friction between the wheel and the truck. And the vacuum, we're using a partnership with the Leibold. Leibold is the first company in the world, more than 150 years old, and who specialize in vacuum pumps, and is the company who supplied the vacuum pumps for CERN Collider in Switzerland. And we're using the same technology, and I will show you later some pictures of these vacuum pumps. A pylon, I said earlier, it's reinforced concrete structure. It's I mentioned at the beginning is the whole system, capsule, tube, structure. It can monitor itself, and it can alert of any defect. Seismic is typical seismic isolation, and the system could be built anywhere around the world, and there are different ways it could be built. It could be built elevated, which is the preferred option, because if you build your system elevated at 5.5, 6.5 meters high, you can use whatever you want beneath the system, and we don't intend to restrict the right-of-way of the Hyperloop. We encourage local authorities, our partners, to use the right-of-way beneath the system and benefit from the shading from the system, to use it for anything from recreation, playground, you name it, gardens, and could be used. And the same can be for the pylon, and the pylon could be potential for energy storage. On the station, we finished the first concept of station, a dewdrop station. You can see on the top left-hand side of the screen is a typical station, and the bottom left-hand side is how these platforms and how you can use it up to 3,600 passenger per hour. This is the first option, but this is being developed as we speak, and the station could be elevated, and it's also could be TOD, transport or orientated development, and this is our aim always. When we build a station, we don't build just standalone station. It's going to be transport orientated development. It could be used 1, 2, 3, 4 levels of the building for the Hyperloop, parking, and shopping malls, offices, residential, and for any use. And this way you maximize the land use. The platform in the picture in the middle shows you how you board and onboard the capsule. We envisage the capsule to be in vacuum all the time, and the boarding and unboarding is going to be done by dock lock. And you see the picture of the dock lock. This dock lock is similar to the space station, and how you can get in and out without vacuum and vacuum. And the reason for vacuum and vacuum is fatigue. If you put your capsule in vacuum and vacuum, it will causes fatigue problem. And also the system can be integrated with the other mode of transport. My computer is frozen.
No worries. Do you want to escape and retry? Maybe you can stop sharing and resharing.
No, let me try again.
Sure.
Yeah. Yes. Okay. Sorry, everyone.
Yeah, no issues, Sabih.
Can you see her now?
Yeah.
Okay. I need to go back. For some reason, it jumped.
Sure.
Okay. The Hyperloop as a technology is not standalone technology. It will have huge impact and withdraw from, as I said earlier, from other technology, from aerospace technology, from aeronautic technology, advanced materials, composite, high strength concrete, green technology like solar, passenger experience. The way we envisage the experience of being in a Hyperloop system is going to be effortless, no hassle. Magnetic, 3D printing, and the biggest impact is real estate. The real estate is we know basically, if you live around transport connection, the value of the property and the rent is higher. And this is now in Dubai. Basically, at the beginning, when Dubai Metro was built, everyone thought no one going to use the Dubai Metro. Everyone use cars here. But now, if you want to rent or buy a property around the Dubai Metro, the value of the property is between 25 to 40% more expensive than if it's not close to the the metro. And the same is going to be happening with Hyperloop. Where we are with the technology, where we are with the current development. Basically, at this stage, and I'm talking about Hyperloop transportation technology, we finished the first full-scale infrastructure system in Toulouse. You see the pictures, and I will show you a video later about it. And this first full-scale 4-meter diameter tube. I meant to mention the size of the tube is 4 meters, and this is the minimum size that you can put for passenger, and the capsule size is 2.7 meters. And basically, one is now is the system is complete. We done the vacuum testing, and we have a full-scale capsule there, and we are in process of integrating the capsule and inside the tube, and we start levitation and propulsion. And the next stage is we're working on a project in Abu Dhabi in Al Ghadir, and it's basically is going to be a research and development and visitor center and 2 to 5 kilometers commercial prototype that people can come visit and use to have the Hyperloop experience. And then hopefully by 2025 we would have the first commercial line available to be used as public transport. And during all this, basically we doing testing and certification continue. And the capsule, as I said, is a composite material. The full-scale tube in Toulouse. Insurance is one of the biggest problem with infrastructure project is if you don't have insurance, you won't be able to build any infrastructure project. And recently we have a paper published by Munich Re, which basically said the system is insurable, and that's basically one of the biggest problems we faced when we talking to financial institution, and that's it now is a fact and not an issue. Vacuum, I already talked about the Leibold vacuum system. The indoor track magnetic levitation is developed by Lawrence Livermore Laboratory. And we have exclusivity to use the system. And certification, we now in discussion, and we started the first set of standards and regulation that we shared last year with the European Union and also with the US Department for Transport on the first set of standards. As I mentioned earlier, we done 2 detailed feasibility studies, and the numbers and the details of the Ohio study is available on the internet for anyone to access, and can see all the work we done for the Ohio feasibility study. We also work with different entities and organizations on not just Hyperloop as a system, but we work with cybersecurity, blockchain, passenger experience, and we want the passenger experience. I can't tell you too much, but we're going to announce an MOU with major Middle Eastern airline to work with them on the passenger experience, not just for, they want to use our concept for passenger experience on their airplane. And this should be announced very, very soon. machine learning, also IoT mobility, all these working with universities, working with research institutions. We have an MOU with Cambridge Center for Smart Infrastructure to work on monitoring a system for the Hyperloop, for the tube, for the capsule, and for the pylon, and even for the piles. And this is basically, you can see here, the Toulouse, and just briefly about the Toulouse project. The Toulouse project started back in 2017. We signed an MOU with the French government. We were giving land, and you can see from the picture in Toulouse, Francazal Airport. Francazal is basically is the advanced hub for new technology in France, and for aerospace research, and we were giving land, and you see the first 320 meters tube, and the research and development center, and basically the agreement with the French government. We're going to hire French nationals to work with us, and we share the cost of the salaries and expenses for the engineers hired by Hyperloop TT. Also, we got a grant to work and develop standards, technologies of Hyperloop in France. And there is a small clip on the system itself, and hopefully. And as I said, this is the some pictures from the Hyperloop Center in Toulouse, and we're talking to different countries, entities, and the Middle East, a number of countries, including the Al Gadir project, which is basically is going to be research and development center where we can bring all our partners and local partners to work on the technology. We hire local engineers and technical people and staff, and the way we envisage of building the system, it's always going to be in partnership with the local entities, local universities, government, and private sector. And these are the pictures of the video just saw with tube, capsule, pumps, and the way we're going to use the pumps is basically we're going to have pumps in containers, in modular containers, and self-contained modules, and we at the moment we need one of these containers each kilometer, and the way we going to build it, we're going to build every 10 kilometers a center 10 containers where you have the vacuum pumps and all the maintenance. If there is a need for maintenance, we're not going to do any maintenance on site. Basically, we take the container away and bring new one. This way you have control and better access to the system instead of repairing on site. As a company, we are around the globe. And as I said, we've done a number of feasibility studies around the globe. And we're talking to different countries everywhere from Europe, United States, China, India, and other part of the world. And as I said, in Abu Dhabi, we've done the first ever complete feasibility study between Abu Dhabi and Align. And this was done in 2016, 2017. And at the end of the feasibility study, we done a number of recommendations. And one of them is basically, we said instead of building complete commercial Hyperloop system, we prefer to build, a section where we can demonstrate the technology and 5-10 kilometers, and after that we build a commercial system. And based on that, where the Al Ghadir project is coming. And this is the recommendation from the feasibility study in Abu Dhabi Align. Again, it's not just Hyperloop TT. There are a number of companies around the globe, including the Elon Musk Boring Company, Virgin Hyperloop One, which is active in India as well, Transport, and Hydrat, which is basic spin-off or university competition team. This, I conclude my presentation, and I hope you enjoyed it, and I'm happy to answer any questions you have.
Great, thanks a lot, Sabih. I think there are lots of questions coming up as you were talking through various subjects. I think Mr. Tuteja has got some questions. Mr. Tuteja, would you like to unmute yourself, switch on your video camera, and ask a question directly to Sabih?
Good evening. For a very nice presentation, Mr. Khali. There is a particular concern in my mind. What are the safety standards adopted for this Hyperloop system? Like for transit systems, you adopt CERLEC or EN standards. For SIL levels are there, SIL certification, and that process is very well established. So for Hyperloop, what are the systems which are adopted? That is the first question. And the second question is about the carrying capacity. You have mentioned that each capsule will carry about 40 to 50 passengers and at a headway of about 40 seconds. So 40 seconds, that translates to just about capacity of about 4,500 passengers per hour per direction, which is very low as compared to the mass rapid transit systems like metros and local suburban trains. So,
okay.
And another third question is, what is the technology which is adopted to maintain safe separation between the two capsules?
Okay, yes. Do you want me to start with the last one because it's easier?
Okay.
The technology used, as I said, we're not going to reinvent the wheel. We're going to use the Hyperloop. Believe it or not, there is nothing new in Hyperloop. Everything tried and tested, and the history of transporting people in tube is not new. And the technology for separation between capsules is already being used in all the cars, all the trucks. It's not something new. Basically,
it's not something new, but the point is that even the autonomous cars are still, the safety worthiness is still to be proven to the fullest extent. Like in the mass rapid transit systems, we are using communication-based train control system, which is a well-proven system and able to achieve a headway of about 90 seconds with a PHPDT of about 70,000.
Okay, yes, I agree with you, but we're not going to put from day one capsules that's 40 seconds.
Yes, but technology, yeah. but the technology what you put has to be scalable and has to be able to maintain that separation.
Absolutely, but we're not going to start from day one going to 1200 kilometers an hour. We're going to start with, that's why we have the Al-Gadir project where we're going to use it as demonstration and testing as well. And therefore, could be resolved within time. The first question is it's on the standards. What standards we are using is basically the standards from rail, from airspace, and from spatial standard. We're working with TUV suit, which, as I said during the presentation, we submitted our first set of standards, and this is going to be reviewed by the European standards and the Department of Transport in the United States.
So I do hope that fail-safe technology systems or fault-tolerant systems are being adopted for this venture.
As said in my introduction on the safety, we know the biggest problem in any transport system is either outside intervention or human error. Yes. And in this case, it's not going to be the case because it's all automated.
Yeah, that is all very, very well said. But even in the automatic systems like unattended train operation, Goa 4, what is being adopted in the metros now worldwide, they adopt a very, very safe systems with a lot of redundancies and all that. So I hope that would be taken care of. I'm not questioning that. So, and the third question about the capacity still remains.
Capacity, yes, I agree with you. But at the beginning, as I said, you can't put capsules at 40 seconds between them, and you can get between 28 to 50 passenger. That is first generation. That doesn't mean, I mean, if you think of a train, if you think of a car, if you think on airplane, the first airplane, you had only one passenger. The first train, you had, this is in continuous development.
I agree with you here, but the point is, like, when we start a new metro project also, we start with not a 90-second headway straight away or 120-second headway straight away. We start at 3-minute interval or like that. So, but still, it has to be built to that capacity. The infrastructure has to be built to that capacity.
If we have any issue with the capacity, we can. The system is scalable. When we build the system, it's basically you build your support structure, and if you start with 2 tubes, but if you need, you can. That's one advantage which I didn't mention of the Hyperloop. Basically, I'm a railway engineer. I come from London Underground. I know everything you talk about. I've done building new railways, upgrading London Underground.
I have also 40 years work experience in railways.
Exactly. So, I know that. And we know the repossession of a rail in London Underground. If you are lucky, you have 2 hours windows to work on maintenance. Okay, we know we understand that. And we said from day one, if we're going to do any maintenance, any operation or any upgrade, we build our support structure to take up to 6, 7 tubes. And then you can put on the support structure as many tubes as you want, depend on your system requirement.
Okay, but that would increase the costs.
Sir, today, sir, I would request that there are other questions also coming up. Okay. So let us give chance to. Otherwise, this will become a 2-party dialogue. So let's not get into that.
Okay, thanks.
Mr. Puneet has a few questions.
Mr. Khalid, just one point. Will you share your contact details so that I can?
Absolutely, absolutely.
So I can correspond with you on further on the subject.
No problem whatsoever.
Okay, thanks a lot.
Feel free to share my details. I'm happy to
I will do that. Yeah, Mr. Tuteja, if you can just write your questions back to me, I'll share with Sabih, and we can.
Questions are there already in the chat window.
Sure, no problem. Let's move on to the next queries. We have query from Mr. Puneet. Puneet, would you like to unmute yourself and ask the question directly?
Yeah, thank you, sir, for your nice presentation.
Let us limit, I mean, Mr. Puneet, let's limit our questions to not more than 3, please, because there are other questions coming in as well. Thank you.
Yeah, that's not a problem. I have already put up a lot of questions, which I expect I can get answers subsequently. What I have asked here is that when we are talking about the area which will be required for construction of this kind of a project, I suppose you have already told that this is a 4-meter tube. So
Yes.
that means we roughly required around 10 to 12 meter if we have to construct the two-way commutation between two areas.
Yeah. Yeah, as I said, I mean, I mentioned in my presentation, maybe I wasn't clear, is basically we prefer the system can be built either underground, at grade, or elevated. But we prefer to build elevated because we want people, we don't want to divide people. We want to connect people. Basically, the system can be built up to 6.5, which is the clearance is needed for outside the cities, and 5.5 for in city. And then you can use the system on top. You can put your solar panel where you can generate electricity, but underneath it, you can use it to whatever you want. You want car parks, you want to use playing area for the children, you can use it to whatever you want. We don't limit the use of, and we encourage the use of the right of way for the Hyperloop.
Right, sir. I will just have one more question and then I will sign off. One is that what is the minimum radius? I mean, because that is one of the critical issues while you construct any transport system, especially that is rail-based. Roads, you have more liberty, but in rail-based system, that's one of the very critical item. So what is that minimum radius on which this Hyperloop system can be designed with full speed?
Yeah, as I said, I'm a railway engineer. I mean, I might bridges, but I work for the rail as
I'm
well.
also, sir.
Yeah. I tell you, the biggest question I had, I led the feasibility study in Abu Dhabi line, and the biggest problem I had with my rail alignment from the client is this your question. And trust me, I managed to convince him. I'm not going to reinvent the wheel. I'm not going to. There is a compromise. We're not going to go 1,200 kilometers an hour everywhere. It cannot be done because it's impossible. And therefore, you have to compromise between speed and right-of-way land available. And we're going to use the same criteria for the design of high-speed rail. It's not different from high-speed rail. And there are ways of dealing with the super elevation. You can do super elevation on the tube itself. You can do super elevation inside the tube itself. And we also envisage super elevation within the train, the capsule itself. And we know the Virgin trains. It's not something cannot be resolved, but it's a high-speed profile. And if we need to get smaller diameter, it could be done, but we cannot go at high speed. You have to slow down and then you speed up.
Okay, thank you.
We have question from Abhijit Kulkarni. Abhijit, would you like to unmute yourself and ask the question directly?
Yeah, hi, thanks. Look, great presentation. I've lived in Dubai for about 15 years, and I know the terrain. So I kind of feel that yes, it is probably the right terrain to have this sort of development. It's reasonably flat. The question I have is there any limitation on the type of terrain? Because suppose if you want to use that for a country like India, you might have varied terrain categories. Somewhere you have hillocks and hills, somewhere you have flat terrain. So is there any adverse effect of certain terrains not suitable for this sort of mode of transport?
Okay, before I answer your question, I strongly recommend you Google Ohio feasibility study and you have all the terrains there. The Hyperloop can be built anywhere, and desert, elevated, tunnels, you name it, it can be built. There is no limitation on building the Hyperloop. But it's if you look at the feasibility study of Ohio, it's give you the type of terrains we envisage to build. And by the way, we moving to the next stage of the feasibility study. It's the government is so pleased with the feasibility study, they ask us to take it to the next level of maybe implementation, and we're talking to private sector to be part hopefully building a system research and development center in the US.
Okay, thank you.
Great. Mr. Chauhan, MC Chauhan, you have a few questions. So can you unmute yourself and ask the question directly to the speaker?
Yeah, thank you so much. It is quite informative. I have 3 questions. What propulsion system you use? I think linear induction motor would be used in this Hyperloop. Second, right of way, you have mentioned 12 meter, but actually elevated metro only pier diameter. Without that space, leaving that space, you can run the buses also, car also. So whether same type of system can be in this Hyperloop system. Another, what is the cost per kilometer? Of course, it has yet to be commercial operation, has yet to be started. But roughly, what is the cost per kilometer?
Okay, on the system is, as I said, we envisage one column system as a T section, similar to what you use for the metro. And you build, as I said, you build from day one the support structure that can take multiple tubes, and therefore it's what is 1.5, 1.8 meters column, round, circular columns, and then you can build anything around it. We're not going to, sterilize the right of way of the system. On the cost of the system, the cost of the system is depend on different factors. One, where it's going to be built. If we're going to build in India, it's not the same cost as building in Europe or building in the Middle East or building in America. And therefore, there is a variation on the cost.
Say Mumbai, what is the rough estimate for Mumbai?
I don't have the cost for Mumbai because I wasn't involved, and it's not us who did the feasibility study for Mumbai, because it's not being published. The difference between us and the others, we publish everything, and that's why I can't tell you from our side. And again, I would strongly recommend you read the Ohio feasibility study. The documents are available on the internet, and the cost, it could be up to 40 million per kilometers, $40 million per kilometers.
Okay. Propulsion system, linear induction motor use or
linear induction motor, yeah, is similar, yeah, like linear motor induction.
Like the metro.
Yes.
Okay,
Great.
thank you so much.
Thank you, Mr. Chauhan. Mr. Randir, would you like to unmute and ask your question?
Yes, sir. Thank you for a very nice presentation.
Thank you.
I have 2 specific questions. One is related to propulsion. Sir, whether we are using superconducting magnets for propulsion. This is number 1, sir.
Yeah.
For levitation purpose. And the second question is related with the batteries. Sir, which kind of batteries are we using in these vehicles? Are they lithium ion? Because with the other batteries, the hydrogen management becomes a concern. And third one is a very small question, again related to batteries only. You mentioned that there will be non-contact charging of these batteries. Is it inductive flash charging or any other technology?
Okay.
So these 3 questions.
Yeah.
Thank you, sir.
On the batteries, we working with different manufacturer on developing the lithium batteries, and the latest technologies on batteries. As I said, I'm a civil engineer, but I can't tell you as much as I can. But don't take my answer as cast in stone. But if you want, you can send me an email and I can give you more details on the batteries. But the batteries, we're using the latest technology in high capacity batteries, and the charging, there are different ways of mode of charging. One, we're looking at either fast charging at the station or replacing the batteries at the station, but technology is being developed as we speak. It's not going to be the same battery system which is going to be used from day one. It's continued development, it's continuous, different companies, different technologies. On the magnet, it's high capacity, high strength, medium magnets.
Superconducting, sir.
Yes.
Thank you, sir. Thank you very much.
Great. Thank you very much, everybody. So I think with that, we will close. I'll just ask a closing question, probably, Sabih, to you.
Yes.
So when are we likely to see something happening on ground in India as far as Hyperloop is concerned?
Okay, I did not mention it, but I spent a couple of weeks in Hyderabad, and we done a pre-feasibility study in Vijayawada, and the feasibility study done. We shared the results with the state, but because of the election and what's going on now with the coronavirus, hopefully after some sort of normality back, I'll be back in India, and maybe I'll see you there. But we working with the Indian government, Hyderabad government, to try to develop a Hyperloop system in India.
Wonderful. Great. I think with that concluding remark, we will end this session today. I sincerely thank Sabih to give us a wonderful presentation about a very interesting technology, and we'll sort of wait to see what's in store for us through this Hyperloop technology, and how this will actually influence the way we live today. And going into tomorrow, if we really see more Hyperloop projects coming up, I'm very sure we'll see a significant social change and economic change in the country as well. So with that closing remark, I thank everybody who joined us today. And for those who are interested to receive a link to this particular video presentation, I can share the details. If you can just contact me and let me know accordingly. So with that, I thank you, and you all have a good weekend. Thank you very much, and have a good evening. Bye-bye.
Thank you very much, everyone, and I really enjoyed the presentation. And as I said, if you need any information, anything, feel free to drop me an email. I will promise to answer you, but bear with me if I don't answer you the same day. That doesn't mean I'm not ignoring you, but definitely I promise you, and Rajiv can...
Could you please type out your email in the chat?
Sorry?
Could you please give your email address in the chat window?
Yes, I will. Please share it with everyone.
Sure.
Rajesh, you will do it.
I will do it. I will do it. Yeah, no problem.
Okay, thanks.
Good.
Thanks.
Yeah, thank you very much.